So our next chapter is on Laplace transform. So we are going to apply some transformation to a function. Okay, why we have to transform? Okay, from what form to what form? That is why you will learn this Laplace transform. Okay, so before this, right? Before this, what we have learned is differential equation. Okay, we have what? We have y double prime, y prime. So now, for this Laplace transform, let's say you have a differential equation in terms of t domain. Okay, you will sometimes you will face some sort of a complicated function, right? So in terms of uncomplicated that function, we apply some transformation. Okay, there are a lot of transformation types. We have Laplace transform, we have Fourier transform, we have Z transform, and many more. Many transform, but we are going to focus on Laplace. Okay, why we transform? Because we just want to transform in terms of another domain. Let's say S domain. Okay. So we have a function, differential function. Let's say we have in t domain, time domain, and that kind of function is quite complicated. That's why we apply transformation. Now, after we transform, we will have another domain, which is S domain. Okay, so starting here, we have, let's say we have ft. Now we transform, we have what? We have S domain. Okay, a function of t time here now change to S domain. Then what? Then we need to solve the function in S domain. Okay, we need to solve the function in S domain. And again, what you need to do is to inverse transform. To get the solution in T domain. So our original problem is in T domain. Remember, this is our original. Originally, it is in terms of T. After we transform, we have in terms of S. Now, this is a transform version. Okay. Then, what you need to do is to solve that function in S domain. Okay, and then you apply again the inverse transform to get the solution in T domain. So previously, in chapter 1 and chapter 2, what we did is directly solve this differential equation to get the solution. Okay, this is direct solution. But now, instead of direct solution, we have first, we need to transform. Okay, and then we have S domain function. Then we need to solve the function in S domain. And then we apply the inverse transform to get the solution. So previously, in chapter 1 and chapter 2, what we did is to solve the differential equation directly from the original domain. If you have X, then you just have the solution in terms of X. But for this one, we apply the transformation first. Is that clear? This is the whole story on transformation process. Understand? Understand or not? Okay, so this is the whole story of what we're going to learn. Okay, we want to solve the differential equation in terms of S domain. After we transform, we got the solution, then inverse transform again to find the solution in our original domain. Okay, so what we are going to learn is how to transform, how to inverse transform, what are the conditions of the transformation. So this chapter is going to focus on that. Okay, so this transformation that we're going to use is Laplace transform, and this is inverse Laplace transform to get ft back. Okay, we inverse S domain to get ft, we transform to get fs. So this is the idea. So now let's take a look on the chapter. So these are the contents. You are going to learn what is the definition of Laplace and what are the properties involved and how can we transform the special types function. Okay, the definition, the properties. Okay, this is special types function, and then how can we apply to inverse transform. Okay, once we know how to transform and inverse transform, okay, once you know that how to transform and inverse Laplace transform, only then you can solve the IVP and DVP problem. You can solve the differential equation by using Laplace. So this is the idea. All right, let's start. Okay, shall we start? All right, now this is a definition of Laplace transform. So by using definition, a function of ft can be transformed to fs. Okay, ft can be transformed to fs by using Laplace transform by integrate exponent minus st times with ft with respect to t from 0 to infinity. So this is the definition of Laplace transform. Okay, so usually we are going to have the table of transformation which are given in your formula list. Okay, but you need to know on how to transform by using definition, because sometimes you are asked on how to convert, how to transform by using definition. Let's take a look one by one here. Can you see this? I think I need to use another one. Okay, hold up. All right, can you see this?
Yes.
Okay, we're going to compare our transformation by using definition and also by using table. Okay. So now, here, as you can see, this is a definition of Laplace transform, where if you want to transform ft, okay, if you want to transform ft, Laplace transform of ft will give you fs. How? By integrate from 0 to infinity of exponent minus st times with ft with respect to t. So now let's take a look at the first example. We have used the definition of Laplace transform to find fs if ft equals to a. Okay, by table, if your ft equals to a, then your fs is a over s. So how can we prove this? By using the definition. Okay. So now, in order to Laplace transform here, we are going to integrate from 0 to infinity exponent minus st times with ft and ft equals to a. So times with a with respect to t. And a here is a constant, just put a outside, right? So integrate this with respect to t from 0 to infinity. Will give you what? Will give you exponent minus st over minus s, right? Then integrate from 0 to infinity will give you a minus 1 over s, 1 over exponent st. So minus a over s, 1 over exponent to the power of infinity minus exponent to the power of 0. Okay, so this one is what? This one is 0. This one become 1. So here we will have minus a over s, 0 minus 1 will give you a over s. So this is your fs. Okay, proven, right? So now if your ft is a, then your fs is a over s. Is that clear? Okay, so a is a constant, right? A is a constant. Then for another example, if ft equals to 7, then fs equals to what? Anyone? If your ft equals to 7, then what is your fs? 7 over s, yes. So for any value of constant, let's say if your ft equals to exponent is a constant, then your fs is exponent over s. So for every constant, if the function is constant, then the function of s domain is constant over s, a over s there. Is that clear? Okay. So that is how we transform a constant. Okay. Now let's take a look at the next example. We have exponent at, example 2. So by definition, by table, okay, because by table, if your ft is exponent to the power of at, then your fs is 1 over s minus a. So now, by definition, if you want to find fs, then it is integrate from 0 to infinity exponent minus st times with ft, where ft is exponent at with respect to t. Okay, same with the definition, right? If you want to have fs, it is equals to integrate from 0 to infinity exponent minus st times with ft, where your ft is exponent at. So just integrate this. Okay, so simplify here, you have what? Simplify here, you have exponent minus s plus at, right? And then, sorry. Okay, dt, then integrate. Then you will have what? Negative 1 over s minus a, 1 over exponent negative s minus at, integrate from 0 to infinity. So you will have negative 1 over s minus a, 1 over exponent times s minus a times infinity, minus with 1 over exponent to the power of 0. So this is 0 This is minus 1. So minus 1, 0 minus 1 will have 1 over s minus a. So this is your fs. Again, compare to the table. Okay, when you have exponent to the power of at, then you should have 1 over s minus a. Is that clear? Anyone has question? No question at all? Understand it all? Okay. So if your function is exponent at, exponent to the power of at, then your fs become 1 over s minus a. So now, if your ft equals to exponent to the power of 3t, then your fs will become 1 over s minus 3. Just follow this. When a is a, then this one s minus a. Now, a equals to 3, then 1 over s minus 3. If ft equals to exponent minus 3t, then your fs become 1 over s plus 3, right? Just s minus minus 3. Okay, is that clear? So this is how you use the table of transformation given here. Okay, any question for these two types? Done with this one. Okay, take your time, understand this. Anyone has question, you can ask. We have negative at the exponent. Which exponent? Oh, sorry, this one. Okay, thank you. Okay, there is no negative here. All right. Okay, everyone. Are we good? All of you understand this? Right. So this is how we transform. Okay, next. What if we have in terms of a piecewise function? So how can you transform this kind of function? So what you need to do is to transform one by one. Okay, now by definition, if you want to transform, if you want to if you want to Laplace transform this ft to get fs, so you will have to integrate from 0 to infinity exponent minus st times with ft dt. And now your ft has 3 types of function with a different limits. So we have to apply it one by one. So from 0 to infinity, but here we start from 0 to 5. Exponent minus st here times with 2. Okay, then we move to the next function from 5 to 10. Exponent minus st times with 0 with respect to t, and from 10 to infinity, exponent minus st times with exponent for t with respect to t. So this is how you transform one by one of this piecewise function according to the limit. So we have by definition, we have from 0 to infinity, but we use these three functions and integrate one by one according to the limit for each function. So we have 0 to infinity, but within this limit, there are three functions that we need to consider with a different limit. So that's why we need to apply this one by one. Okay, so this one from here, you just can integrate one by one according to the limit here. All right, can you do this? Okay, try this. This one, no need, because this is 0. So no need to do this integration. Just focus on the first part and the last part. All right, try. What should you get? Okay, so we cannot use the table of transformation directly. Why? Because we have piecewise function. Because for each function, we have different limit. This table is only applicable for the definition of 0 to infinity. Okay, but for this one, we have 0 to 5, 5 to 10, 10 to infinity. So you need to integrate one by one. But based on the definition, you always need to multiply with exponent to the power of minus st there. Is that clear? Okay. All right. Now, from this example, you can try to use the definition of the Laplace and find the transformation for partial test 2 given in the notes. It is quite same with the example 3 here. Okay, you can try. All right, so now let's proceed with Laplace transform properties. Okay, okay. Other than this example, all right. Let's say you have sine, you have cos, you have sin, you have cos. In order to get the function of s here, we always use this definition. Okay, we always use the definition of this Laplace transform to obtain from ft to fs here. Okay, so this ft to fs, we apply Laplace transform. After this, we are going to reverse the process from fs to ft by using inverse Laplace. Okay, but let's just focus on how to transform first today. Okay, shall we proceed? May I proceed? Okay. Okay, while doing the next example, after this, you are going to face many more functions instead of constant and exponent here. We have a lot of functions here. All right, so now let's proceed with the properties of transformation. Okay, let's start with the properties of linearity. Okay, this is our first property, linearity property. Okay, so in linearity property, all right, in linearity property, it is important for you to understand all the properties, because after this, we are going to have a lot of types of function. So let's begin with this linearity property. So what is linearity property here? Now, this linearity property is involved only on addition and subtraction, okay, plus minus and scalar multiplication, okay, addition and subtraction, and this is scalar multiplication. Okay, so these two are the linearity property applied to Laplace transform. So if we have f1 plus minus of f2, by linearity, it can be parted to transforming f1 plus minus transforming f2. And if you have a transformation of CF, then this C is a constant, then you just can put C outside. Okay, just like, no, none. Okay, this one. Okay, so now let's take a look at this example. We have Laplace transform of 1 plus 5 exponent 4t minus 6 sine 2t. So by linearity, you can divide it one by one here. Okay, you can divide this to one by one transformation here. Okay, by transforming one by one of 1 plus transforming of 5 exponent to the power of 40 minus transforming of 6 sine 2t. So you just transform one by one. Laplace transform of 1 will give you what? Laplace transform of 5 exponent 4t will give you what? Laplace transform of 6 sine 2t will give you what? Then you just can add them together. Okay, so for this, you can check directly from the table. Okay, now 1 is a constant. So Laplace transform of a constant A will give you A over S. So Laplace transform of 1 will give you what? Will give you what? Okay, so 1 over S. Now, this is Laplace transform 5 exponent 5t. And from the linearity property, if you have C times with F, where this C here is 5, then you just can put 5 outside. So 5 here is a constant. And you can see this is transforming exponent to the power of 4t. You have exponent to the power of 80 becomes 1 over S minus A. Now, exponent to the power of 40 will give you 1 over S minus 4. So, will give you 5 over S minus 4. So, this is where the scalar multiplication from linearity property is applied. Okay, so this is your scalar. Put that scalar outside. Then you just can form directly from the table. All right, so now this one, 6 is a scalar. Put 6 outside, then transforming sine 2t. Okay, when you have sine at, the transformation becomes a over s squared plus a squared. So now you have what? You have sine 2t. So this is your a. So we'll give you what? A over s squared plus a squared, and a is 2, so a over s squared plus a squared. So this is how you transform. Then put the transform version of this fs to here. Again, you should fill up this full equation here. So 1 over s plus 5 over s minus 4 minus 12 over s squared plus 4. Why minus? Because the original function is in terms of minus here. Is that clear? Anyone has question? Everything's good? Anyone has question? Anyone has problem? Come on. Okay, good. How about the rest of you? Okay, up until now, from 1 to 10, where are you? All right, so what we have learned just now, wow, infinity, good. Okay, what we have learned just now is how to transform. So, how to transform? How to transform? There are two ways to transform. The first is by using definition. Then, table of transformation. Okay, and in each of these transformation, we are going to learn about the properties. There are properties that we need to consider. Okay, now we have done with the first property, linearity. Okay, next, it is first shifting property. So what is first shifting property? Okay, let's try this. Okay, in first shifting property, as you can see here, in first shifting property, right? Be focused, everyone. If you transform ft, you know that you will have fs. Okay, from the definition, if you transform ft, you will have fs. Okay, now by first shifting property, if you transform ft multiplied with exponent at, then we will have fs minus a. Okay, so let's prove this. Okay, now you want to transform this. Like Laplace transform of exponent at ft. Okay, by definition, it is always integrate from 0 to infinity exponent minus st times with ft, right? But now you have this whole function, so times with exponent at ft with respect to t. Okay, understand or not? Up to this point. So basically, previously, we have ft only, right? We have ft here. We have ft, then exponent times with ft. But now this ft now is exponent at ft. So this is your ft now. So by definition, this exponent minus st times with ft. So this is your ft. Okay? So now integrate this, it'll give you what? Okay, so now this one is from 0 to infinity. This one become minus s minus at. Okay, ft. Right, so let do some assumption to simplify the function. Okay, let s minus a here become r. This one. So we have here exponent minus rt all right, times with ft dt. As you can see, when you apply the definition, okay, this is the definition. Become fs, right? So if you have here r, then it become what? Become what? Anyone want to try? Yes, fr. Okay, so we are going to have fr. If transform ft, we have integrate from 0 to infinity, exponent minus st ft become fs. Okay, here we have s, here we have s. So now here we have r, so we will have fr, which is fr is fs minus a. So it is proven. Okay, when you have ft multiplied with exponent at by first shifting property, the transformation becomes fs minus. Okay, so proven. Okay, let's take a look at the example. Example 4, we want to transform we want to transform exponent to t times with t. So from this example, what is your a? According to this form, according to first shifting property, what is your a? A equals to what? Okay, a equals to 2. And ft equals to what? Ft equals to t. So when ft equals to t, transforming ft will give you fs. So what is fs here? If your ft equals to t, then your fs is what? Look at the table of transformation. When your function is t, where is t? So this one, t to the power of n, where n is 1, right? Then the transformation is n factorial over s to the power of n plus 1. Okay, from the table, when your function is t to the power of n, the transformation becomes n factorial over s to the power of n plus 1. So now we have t, which is t to the power of 1. So here we will have 1 factorial over s, 1 plus 1. So you will have 1 over s squared. Is that clear? Follow the table of transformation. Understand or not? Anyone has question on this? The function here is t. And you know that t here is to the power of 1. So if from the table of transformation, if the function is t to the power of n, the transformation becomes n factorial over s to the power of n plus 1. And you know that this n here equals to 1. So it will become 1 factorial over s to the power of 1 plus 1. So transformation t becomes 1 over s squared. Is that clear, everyone? Okay. Where does this come from? This come from the table of transformation here. This one. Okay. The third one and the second one. So now when your A equals to 2, ft equals to t, and you know that fs equals to 1 over s squared. So by first shifting property, transforming exponent at times with ft becomes fs minus a. And now we have exponent to t times with t, you will have fs minus a as fs minus 2 squared. Is that clear? Because this is your fs. This is your a. So fs minus a should be s minus 2 squared. Okay, clear now? This is first shifting property. Anyone has question? Okay, guys, understand or not? All right, clear? So this is first shifting property. Okay, let's try another example. Okay, let's do this together. Again, first shifting property. So mapping to the first shifting property, you know that transforming exponent at times with ft will give you fs minus a. So this is mapped to the first shifting property following the form of the function. And you know that from here, what is your a? A equals to what? A equals to 4. Okay, good. What is your ft? Ft equals to cos t. So when ft equals to cos t, then you can transform ft to get fs, because we want to have fs minus a. So ft equals to cos t, fs equals to what from the table of transformation? Ft equals to cos t, then the transformation become s over s squared plus a squared, and a here is 1, right? So you will have s over s squared plus with 1, right? S over s squared plus with 1. Okay, now this is your fs. Then what is your fs minus a? You have your fs, you have your a, then just substitute. So fs is s over s squared plus 1. So fs minus a should be s minus 4, s minus 4 squared plus with 1. Okay, is that clear? Any question? No question. Okay, let's try the example. Okay, let's try partial here. Partial question. This one. Okay, A and B. Try. T cos to t exponent minus 2t cos to t. Oh, sorry. This one. T. Okay. Let me explain the first. Let me explain another multiplication here, another property here. Sorry. Okay, let's try another property. We have done with first shifting, and we have also done with the linearity. So the next property is multiplication. Before we can proceed the partial question, let's try this. try to understand the next property here. Multiplication by t to the power of n. Okay, previously we have ft times with exponent at in first shifting property. So now in multiplication by t to the power of n, we have ft multiply with t to the power of n. Okay, so let's try another example here, example 6. Okay, let's do this example while understanding the concept here. Okay, now as you can see, it is a combination of ft multiplied with t to the power of n, where n equals to what? N equals to 1, right? Okay, now when you have a combination of t to the power of n times with ft, the transformation become -1 to the power of n dnf over dsn. So now you need to have what is your n and what is your ft. What is your ft? Ft is sine 60. When your ft is sine 60, what is your fs? Remember, fs is always obtained by transforming ft. So what is your fs? Okay, 6 square over s square plus 6 square, right? Is it from the table? Sine a over 6 square plus a square. Sorry, there is no square. So 6 over s squared plus 6 square, which is 36. Is that clear? So, in order to transform this, then transforming t sine 60 will give you -1 to the power of n. N is 1. So, differentiate about n. So, differentiate once of f with respect to s. So, no need to write 1 here. Then you just have -1 differentiate 6 over s squared plus 36 with respect to s. Differentiate this with respect to s will give you what? Will give you -12s over s squared plus 36 over squared. Okay. Multiplied by -1. Okay. Then will give you 12s over s squared plus 36 squared. All right. Everyone got this? All right, done. Alright, guys? All of you got this? Anyone has question? Okay. Now, this is the multiplication by t to the power of n property. Okay, let's try first equation. This one. Okay, as you can see here, we have t cos 2t. This is multiplication by t to the power of n. This is first shifting property. You can try this too. Okay, try it. Anyone has question? Anyone has problem? All of you got this? Guys? For teacher FS, for Kosh. Alright, everyone got up to this form? Okay, so just differentiate that. So what should you obtain from here? This one is differentiation of quotient rule, right? Done? All right. Anyone has question? Okay. No question. I think all understand. Right. So now what we have done just now is how to transform. Okay. How to transform? Basically by using the definition and by using the table of transformation. So you know how to apply the definition and you can know where this table of transformation comes from. So basically all of this comes from the definition, right? If you want to prove this one by one, you will obtain the same result in your FS here by definition, okay? Once you know how to apply the definition, you can implement the definition in terms of properties. We have linearity, we have a shifting, we have multiplication by t to the power of n. Okay, let's just stop up until the third property here. In your notes, we have a lot of property. After this, we're going to learn about second shifting, special types of functions. So, okay, let's try the last example for today. As you can see, what is the property involved here in example 7? What we have learned just now is linearity. Okay. Addition, subtraction, and scalar multiplication. And we have first shifting. And we also have multiplication by t to the power of n. So now, from this example, what are the properties involved? Yes, it is a combination of multiplication by t to the power of n property and also first shifting. Okay, it can be mapped to what? Exponent at times with ft, where your ft equals to t sine 2t, and this is t to the power of n property. All right, this one is, so initially it is first shifting. Okay, once we simplify to EATFT, and you know that your FT is t sine 2t, and this t sine 2t is t to the power of n property. So you need to do it one by one. Okay, first, you know that this is first shifting by following EAT times FT. So in first shifting, what you need to know is A equals to -1, right? And FT equals to T sine to T. So in this, you know that N equals to 1, okay? And Ft equals to sine to T. So you can have your Fs, where S equals to 2 over S squared plus 4, right? Sine A over S squared plus A squared. Okay? Okay, up until this point, anyone has problem? Anyone has question? So, you have your N, you have your Fs, then transforming T sine to T will give you -1 to the power of N. Differentiate the function here about 1s because N equals to 1. Okay, so this one will give you what? Okay. For S, 2 times 2S for S squared minus 4 minus 1 minus 1. Okay, will give you right? This one, right? All of you got this? Then this is your Fs. So from here, you know that this is mapping to what? Fs minus A. And you have your Fs. This is your Fs. And you have your A. So it will give you 4s minus minus 1, s plus 1 over s plus 1 squared plus 4 squared. Okay? So this is how you transform because this involves two properties altogether. All right. Anyone has question? Okay, everything's good? So up until these three properties, from 1 to 10, where are you guys? How about the rest of you? We have 53 participants and only 3 to 4 of you respond. How about the rest of you? All of you, are we good? Okay. So of course, you need to have a lot of practice here. You can try tutorial. Okay, let me show you the tutorial. All right. So in this tutorial, as you can see, the first one here, we just use the definition. You can always check from the table, but as you know that this piecewise function cannot use table directly, so apply the definition. Okay, and then this one, use Laplace transform to find Fs where it involves properties. This is linearity, this is linearity, this is first shifting. Okay, this one is linearity, this is first shifting, linearity, this is first shifting plus with t to the power of n, this is t to the power of n, and first shifting, this one is t to the power of n, and first shifting also same, this one first shifting and linearity, and this one is sine t cos t. Yeah, ni. Thing is linearity. Okay. So you can try the first and second question from the tutorial. The third one is a special function. Okay, this one we are going to learn this next in our next class. All right. So you can try. Okay. Anyone has question? Yes, the Laplace table will be provided, and sometimes you are always okay. Sometimes the Laplace table maybe it is provided, but sometimes it is not always full table, but you can refer to the past year question. Okay, that is the table that we're going to use. So maybe some function is not there, so you can identify which function. All right.